For this example, we're going to look at finding the volume of a solid generated by this region here. Y equals the square root of x, that's the red curve. The line y equals 2, that's in blue. And x equals 0, which is in green, that's the y-axis. So we're looking at this region here. And we are going to revolve it first about the line y equals 2, and then secondly, we're going to revolve it about the line x equals 4. So starting with the line y equals 2, that's the blue line here. We're revolving it about a horizontal line, so we're going to be integrating with respect to x. And you'll notice here that our region is sitting on that line. Okay, that line forms part of the boundary of that region. The disk method is what's going to be the best choice here. So for part A, when we revolve it around y equals 2, I'm going to use the disk method. So what we're going to do here is we're going to look at the interval. We're integrating with respect to x, again, because we are revolving it about a horizontal axis. So it's going to go from 0 to 4. And it's pi times the radius squared. Now, in this case, to find the radius, it's the distance from the blue line to the red curve. That distance is going to be 2 minus the corresponding point on that red curve, and the corresponding point on that red curve is going to be the square root of x. So we're going to have 2 minus the square root of x as our radius. So if I switch colors here, we're looking at this radius there. So as usual, I'm going to bring my pi in front, and then I need to square this radius. So we end up with 4 minus 4 times the square root of x plus x. Integrating that, we end up with 4x minus, it's 4 times x to the 3/2 power over 3/2. In other words, it's 4 times 2/3, x to the 3/2 power. 4 times 2/3 is 8/3, x to the 3/2 power, plus x squared over 2. Substituting 4 for x, we get 16 minus, and here in the middle, the square root of 4 is 2. 2 cubed is 8, so we get 8/3 times 8, so that's 64/3. Then the last term, 4 squared, is 16. 16 over 2 is 8. If we were to plug in 0 for x, everything would be 0, so I'm not going to worry about that. If we take everything and find a common denominator, which obviously is the 3, we're going to work out to get 8/3 pi as that volume. That finishes part A. Part B is asking us to find the volume if we take that same region, but this time we're going to revolve it around a vertical line, and it's the line x equals 4. So it's this line over here. Because we're revolving around a vertical line, this time we are going to be integrating with respect to y. Additionally, you can see that our region is not sitting on that line, so we're going to use the washer method here. because there's going to be a gap. Because I am integrating with respect to y, my interval goes from 0 to 2. And with the washer method, I'm going to look at the outer radius and square it minus the inner radius squared. The outer radius is just the distance from this left edge to the line x equals 4. Well, that's a fixed line, okay? So that distance from this outer edge to the line x equals 4 is always going to be 4 units. So we'll have 4 squared as our outer radius. The inner radius, this is what will fluctuate. Keep in mind that this red curve here is the line y equals the square root of x, or I can rewrite it as y squared equals x. The inner radius is going to be the distance from a random point on that curve to the axis of revolution here. So that's our inner radius. To find that inner radius, it's going to be 4 minus y squared, okay? So the distance all the way to the edge is 4 minus this value is going to give us what's left here. So again, the outer radius is that fixed distance 4. The outer edge of this solid is always going to be 4 units away from the axis of revolution. The inner radius, this distance here, it's 4 because this line here is 4 units from the axis minus this value here. So what we're going to do next, take care of this. Bring the pi in front. So I'm going to look at the integral from 0 to 2 of 16 minus, in parentheses we have 16 minus 8y squared plus y to the 4th dy. That's a funky looking 4, but it works. (16 minus 16 cancels. The negative makes that negative 8y squared a positive 8y squared. And then it makes it a negative y to the 4th. If we integrate, we're going to get 8y to the 3rd over 3 minus y to the 5th over 5. I'm going to look at that over the interval from 0 to 2. Two cubed is 8. 8 times 8 is 64, so we have 64 thirds. Minus 2 to the 5th is 32, minus 32 fifths. If you were to plug in 0, you're going to get 0 for both terms, so we don't need to worry about that. If you find a common denominator and subtract, you're going to end up with 224 over 15 pi for the volume.